Yeah, we're at the halfway point soon here. All right, so today we are going to talk about factoring. So factoring is one of those things that haunts students because it's very difficult to teach factoring in like 1 or 2 days. You really need several weeks to do factoring correctly. And so each one of you is coming in here at a different level in terms of what you've learned in the past. And so I can try as much as I, get up here and show you examples, give you methods. But if you find yourself struggling, it's because you need more practice. So I would encourage you to go to the lab or come to my office if you need something. We're going to talk about factoring by grouping, factoring GCF, trinomial. So there's different things we're going to look at here. But I want to start with just what is the general idea of factoring. Okay, so let's say we have this expression here. And I ask you to multiply that out, to expand it. I think everyone here is comfortable with the idea of doing the FOIL, right? Okay, so we'd multiply here to here, we get x squared. We multiply here to here, we get negative 4x. Here to here. Please keep an eye on my arithmetic today. When I'm tired, I make lots of arithmetic mistakes. Okay, do y'all agree with that? Okay, and then we combine those middle terms. Okay, this part's the part you'll see in a second that's a little tricky. Okay, we combine those together and we would get 4x minus 8. Yes? X. See? Okay, 4x minus 8. Agree? Yes?
Oh, yeah.
Okay. Just combine those like terms. Let me put a little more space in there. Okay, so that process from going from here, okay, down to here is basically multiplying, or if you like, you could say that's expanding. And that is not what we're interested in. What we're interested in is going backwards. Okay, so what we want to do is we want to be able to go from here back up to here.
Shouldn't that 8x be 2x?
X squared minus, yeah. See, okay. Y'all are gonna have to keep an eye on me.
I was like, wait, am I missing something?
Okay, all right, so let me go through this very slow. X squared minus 4x plus 2x, right? Plus 2x. And then you can add these together, and what do you get? Negative 2x. Okay. I knew y'all were kind of looking like something was wrong. All right, so yes? Now yes? Okay. So going from here back to here, that's called factoring. So what you're doing is you're taking an expression that has, pluses or minuses between these terms, and you're somehow trying to turn it into two things that are being multiplied, all right? Now, something that you could look at as something similar to this would be, if you take 3 times, let's say 5, right? You multiply those two together, you get 15, right? So that's the process from here to here, that's multiplying. And going backwards, right there, is called factoring. And you might remember this from some past class where you would take a number and break it down like this. We call this the prime factorization. Factorization means you're turning something into multiplication, all right? So does it make sense what we're going to try and do? Okay, now the next question would be why, right? Like why would you ever want to take something and turn it into two things being multiplied, all right? So I'm only doing this because I think it's important for us to at least appreciate like why we ever want to do this, right? So let's take this right here, x squared minus 2x minus 8, and let's make an equation out of it. All right, so this right here is an expression, agreed? expression, expression, expression. But what if I came in here and I said, hey everyone, there's an equation. All right, is that a linear equation? No. It's no longer a linear equation because I have x, but I have x squared, right? Okay, so it's not linear, and it is an equation, and there's only one variable, right? So this right here, because we have a 2 here, this would be called a quadratic equation, right? With one variable. And so just like a linear equation, like this equation is linear, right? I could ask you to solve this, couldn't I? And you would like move the 1 over and divide and blah, blah, blah. You could figure out what x is. I could ask the same question here. Solve this equation. Tell me what x's make that true. Does that make sense? And so how do you solve that? Well, you cannot move the 8 over and start trying to get x by itself because you have 2 things that have x in them. And so you're never going to get x by itself like you can here. So what we do instead is we take the left side and we do its factorization, okay, like this, and we turn it into this. So let's take a look at that. If we were to somehow be able to turn this back into what it came from, and now ask ourselves when that's equal to 0, this will be very easy to answer. And the reason why is because, look at this. If I tell you that something times something is 0, what can you tell me about these things? So if I tell you two things multiply to be 0, what can you tell me one of them has to be? 0. One of them has to be 0. Now, I want you to think about that. I know it's the morning. I know you're all tired. But why is it that when you have 2 things being multiplied, one of them has to be 0? Or when 2 things multiply. So if I say 2 things multiply to be 0, why is it that one of those has to be 0? Yeah, because how else can you get 0? I mean, if you have something other than, like, let's say you had a number here like 1/2, right? Let's just say. What does this one have to be to make this thing equal 0? 0. There's no other number. You can't come up with any other number that you can multiply times 1/2 to get 0. There's no other choice but to make b 0. So another way you could do it is you could say, okay, what if b is like 5, right? So I'm saying something times 5 is 0. The only thing that can be is 0. Now, this right here has a name to it. It's called the 0 factor property, and we'll talk about that a little bit more later. But the whole idea is that here, this does not look like something times something, right? Equals 0. So we turn it into something times something equals 0. And then all we have to ask ourselves is, hey, when is that 0? What would make this 0? Can you just look at that and tell me what x would have to be to make this whole thing 0? -2, right? If that's -2. And then here, if x is what would make this 0? 4, right? If x is 4, 4 minus 4 is 0. So if we can get it to this point right here, then we know right now that -2 and +4 would be our be our solutions, would be our answers. Make sense? And I'll just check one of them. Let's just take the number 4. What's 4 squared? 16. Okay, so remember that. 16 minus, what's 2 times 4? 8. Okay, minus 8. And is that 0? 16 minus 8 minus 8? Yeah. It is. So 4 was a solution to this equation. And -2 would also work that way. So if we are going to have any hope at all of solving quadratic equations or equations that are not linear, okay, not linear, we have to be able to factor. If you can't factor, you're kind of dead in the water, all right? So now what we're going to do is talk about the different techniques for factoring, okay? Hopefully that just gives you an idea of why. And does anyone know what a quadratic looks like if you graph it? I know some of you from school, right? Little thing, we call that a parabola. So like that thing we were just looking at actually looks like this, like if you do the graph of it. So it's not a line, it's a parabola. And the 2 answers that we just found are actually where our graph hits the x-axis, right? So later on, we'll be using all of this to figure out what the x-intercepts of a parabola are. Okay, so factoring. Here are the steps. How to factor. All right, first step for factoring. And if I'm pulling sticks today, and I pull your name and I say, what's the first step for factoring? You better get this right, okay? The first step for factoring is, anyone know? GCF. Now, we've talked about GCF before, yes? What's GCF stand for? Greatest common factor. So the first step for factoring anything, ever, is to always look through your expression and see if there's something you can pull out of all the terms, all right? First step. Okay, second step is to count the terms, all right? Count the terms. Now, I'll explain this with an example, all right? For now, let's just write the steps down, then we'll go through the example. So the next step after we pull the GCF is to count how many terms we have. Part A. If there are 4 terms, we will do grouping. That's the technique. This is the technique that we will use, okay? It's called grouping. If there are 3 terms, we're going to do either what's called the AC method, or some of you might have learned something called like guess and check. Yeah, guess and check. Guess and check is definitely the better way to go, all right, in terms of guess and check is faster. But the problem with guess and check is that you have to really have done this before, like in your life, to be good at guess and check. All right, so it takes time to develop this. I can show you the AC method today, and you'll have a method. It works, you know, every time. It's just a little time consuming. All right. All right. If you have two terms, you're going to be looking for the difference of squares. Difference, I'm just going to put diff, of cubes, or the sum of cubes. Okay, you're going to be looking for one of these 3 things. Now, in this class, because this is 13-14, we actually make this class a little easier. So we aren't even going to deal with these 2. We're only going to do this. So if we ever have 2 terms, you're always going to be thinking difference of squares in here. All right, now if there's 1 term, you don't need to factor because a single term is already factored. Anything by itself is already factored. All right, so what we're going to do now is we're going to go through some examples. And for each one of these, I'm going to go through these steps. Always pull the GCF, then I'm going to count the terms. The number of terms I have is going to determine each of these methods. I have not done these, so as we do examples, you'll see what each of these are. All right? So let's begin. There it is. Which one do I want to do here? I don't like any of those. I think I'll make one up to start. Okay, let's go with this one. All right, 3x cubed minus 5x squared minus 6x plus 10. Okay, now I realize that looks pretty bad, but let's just go through and see what we can do here. So the instructions here are to factor. If you're sitting there going, why are you starting with like this big ugly one to start, you know, like why don't we start off simple? It's because we actually, the method we use for this, we're going to use it for when we have 3 terms. So you need to know how to do this one before we do the one with 3 terms. All right, so first step. What's first step? GCF. So, do you see something that you can pull out of every single one of these? So I like to look at numbers first, right? Is there a number that goes into each of these numbers? Has to go into all of them. Something other than 1, because 1 goes into everything. So we don't consider 1. So is there a number? No? Right? There's no number that goes into all those. Then go look for variables. So I have an x cubed here, right? X squared. I have an x, and I don't have an x there. So do I have any variables in common in all of them? No. So there's no GCF here. There's no greatest common factor that I can pull out. Okay, so I move to the next step. Next step, I count the terms. 1, 2, 3, 4, right? So I have 4 terms. So I'll just kind of summarize over here. I have no GCF, right? That was step 1. Step 2, I have 4 terms. And what do I do when I have 4 terms? Grouping. Now let's talk about grouping. So how do we do grouping? You may have learned this already. If you have, I'm not here to try and mess your mind up. I'm going to teach it the way I teach it, which is this. What you do is you look at your first term, you move to your second term, and right after your second term, before this sign, we're going to draw like a little slash mark right there. Just make sure that it's before that sign. All right? And now what we've done is we've taken the 4 terms and we have broken it up into 2 pieces, right? So on the first piece, the one on the left, what we're going to do is a GCF. All right? Just on the first 2. So do these have a greatest common factor? Is there something that these both have in common? What is it? X squared, right? They both have, well, this one has x cubed, this one has x squared. So you only can pull out what they have in common. So you're going to pull an x squared. How about a number? 3 and 5, you don't have a common factor there. So just an x squared can come out, right? So what I'm going to do is I'm going to write x squared. And then in parentheses, I need to give myself enough room to fill in what I need to get that back. So what do I need here in my first piece? 3x. And then what do I need here? Minus 5. So is everyone clear with that? Yes? Okay, and now what we're going to do is we're going to try and do the same thing on the second piece. All right? The same thing on the second piece. We're going to try and pull a GCF out. So is there something that these both have in common? A 2, right? Do y'all agree I can put a 2 into both of those? So they don't have an x in common, right? Just a 2? So at this point, I could pull a 2 out, couldn't I? However, the goal of grouping is to do this on both pieces, and whatever's in parentheses here, we have to have the same thing over here for this to work. So like I need what's in parentheses on this side to be 3x minus 5. It has to be if this is going to work. So instead of thinking about what we want to pull out, I'm going to put over here 3x minus 5, and then I'm going to ask you what would have to go here in order to distribute back through to get back this. -2, right? -2. Yes, you could have pulled a 2 out, but we actually want -2 to come out. So I'm going to put -2 here. And notice if you distribute that through, you get -6x, and then negative times negative gives you the +5, right? Okay. Any questions on that step? Okay, the next step is this next step still confuses students in my calculus class. They know how to do it, but they don't know what they're doing. So the next step, let me write down what it is, and then I'll explain what we did. The next line should be 3x minus 5. That's what they have in common, right? And then, in parentheses, you're going to put the two things that were out front. So in this case, it would be x squared minus 2. All right? Now, a lot of times students are taught to do this, and there's really not a good explanation. Can anyone explain what I just did? I mean, a lot of you, like I said, can do that, but does anyone know like why it went from this to this? No? So let me try and explain it over here. What if I had this expression right here, x squared m minus 2m, and I asked you to factor it, okay? You would do GCF, wouldn't you? What do these both have in common? M, right? So you'd pull the m out. So you'd put the m out here, and then what would you have in parentheses? X squared minus 2, right? Agreed? Okay, that's exactly what we just did here. It's exactly what we did. But this is the m, and this is the m, right? So it's like these two expressions both had the same thing in them, didn't they? An m. So we pulled that m out. Here it is. This is the m. And then what we did is we wrote this and this because that's exactly what you did over here, right? So if I were to distribute this entire thing, right, this whole thing, multiply times that, I get this one. And if I multiply it times that, the whole thing, I get that one. Now, you don't need to like really understand that. I just can't teach it without explaining it because it bothers me. Yes?
Do we have to write it in that order? Or is
I'm glad you asked. So the question is, can you reverse this? Could you do it this way? And the answer is yes, because multiplication is commutative. It doesn't matter. I personally don't ever teach it that way because when you do it the other way, then it's really hard to show a student why it's that.
Your everything I see.
Yeah.
Connection. That's why I asked if
Yeah.
you did it that way.
Yeah. I don't care which way it is. You do it whichever way you can remember it, but it's not wrong to flip these. Okay? All right. Good? Now, we are done. We have turned this into multiplication, right? So we're done. All right, let's do another one. So in the next problem I do, we're going to have some other letters and variables in here. Don't let it freak you out. We're still going to follow the same method. Which one do I want to do? Let's do that one. 15xz plus 20x plus 6yz plus 8y. All right, first step, GCF, right? Okay, do they have a number in common? Only 3 and 5 here, right? Those are the only numbers I can get. And here, this has got, what, 2? And so I don't think we're going to be able to get a 3 or a 5 in here, right? So there's no GCF number, right? No number that goes in all of them? How about letters? Do we have any letters in common? We don't have X's in all of them, right? We don't have Y's in all of them. We don't have Z's in all of them. So we don't have a GCF again. All right, so no GCF. Count the terms. We got 4. We come in here, we slash it right there. All right, let's get you involved. You all look so eager right now to answer that I'll satisfy your desire here. Here we go. Evan. Okay, Evan. So I've slashed it right after the second term. What now? Group, okay. So what do you see in this first 2 that you could do, that you could factor out? 5 can come out of both, right? And always make sure that that's the biggest number you can get out. And it is in this case, 5. Okay, so I agree, we have a 5. How about letters? Anything they both have in common? X, okay. So now I'm going to put a set of parentheses, and what would go in that parentheses, Evan? So you need to turn 5x into 15xz. So turn your 5 into 15. 3, so you'll need a 3 here, and you need an x, right? You already have it, but you're missing z, so z here, right? Okay, now what about here? Just a 4, right? Plus 4, right? Okay. Good. Kristen, you're up.
So then you put the 3z plus 4 on the other.
Good, I like that. Okay, so Kristen's following what I just said, that if this is going to work, this has to be the other factor on the other side. So now, Kristen, you're going to try and figure out what number goes out here that would give you back this, right? Everyone follow that? So what's the number?
Oh, so it'd be 2 and then it would be
2, right? Everyone got that? 2? Now, when you put 2 out here, I want you to make sure you do something. If it's 2, that's a positive number, right? Make sure you put a plus. Now, if it was negative 2, it would be, you would write negative 2, and so there would be a minus there, right? But if it's positive 2, make sure you put plus, because technically if you don't, then what you're saying is it's this times that, and it's not. It's an addition symbol there. So put add. Okay. And then, Kristen, what would be the next line? Now that we've gotten it to this, what would be our next line?
It should have been 2y.
2y. Oh, I didn't hear you say y, and I wasn't paying attention. Yes, thank you. 2y. 2y. Everyone got that? There was a y common and a 2.
So then it's 5x plus 2y times 3z plus 4.
Yes. I'm going to write it the other way. Sorry.
Sorry, I was just.
I'll do it. I'm going to write yours down, though, okay? Because you mentioned it, and so that's the way you remember it, yes? Okay. So those are both correct answers. The way I've shown it is that whatever you have in common, you write that down first, and then the 2 things in front go in parentheses. The way Kristen learned it, you write these in parentheses, and then you write down what they have in common. Okay. We all good? All right. Let's try another one. There we go. Number 9 looks good. 3x squared y minus 6x squared minus 3xy plus 6x. Kiana? All right, so what's first, Kiana? Up, up. First step, always. Right, that's right, okay. Now, if you went straight to 4 terms here, what would happen is that your final answer, even though you get something, it wouldn't be completely factored. Like there would be something that still needs, that could come out. So always run that first step, right? So, Kiana, if you look at this, do they all have something in common here? Start with numbers. Okay, 3. Okay, so they all have a factor of 3 in them, right? All right, how about letters? They all have an X, but no Y's, right? Not in all of them. So everyone agree 3 and X would be a GCF. Okay, this is the first time we've had a GCF, right? So you pull the GCF out, and we did GCF a while back, so do you remember me telling you about like leave enough space here for the number of terms you have here? Okay, so Kiana, do you want to pass the torch or you want to keep going? You'll pass the torch? Okay. To Milena. Okay, so Milena, you want to help fill this in? Okay, so what will we have here? XY, okay. Minus 2x minus y plus 2. What do y'all think? Do y'all agree with her? Yes? So remember, you can always check this. Just distribute that through, right? All 4, and you should get back this right here. Okay, good. Now, we've finished the first step, right? GCF. So what's the second step? We want to count the terms, right? We want to count the terms. Now, when I say count the terms, I mean, and I didn't write this in our notes because I thought it'd be confusing, When I say count the terms, I mean now that you've factored the GCF out, look within this parentheses and count those terms. Right, so we can ignore this. So if you want to add that to your notes, you can. Count the terms in the parentheses. Right, so here, how many terms do we have there? 4, right? We still have 4. We have 4 terms. So since we have 4 terms, we're going to do grouping, which means we slash it right there. Questions? All right. Lisa? Oh, you know what? Lisa's no longer with us. Sorry. That was kind of mean. I feel bad about that. She's a real nice lady. Okay, Rodrigo. All right, Rodrigo. What now? Uh-huh. Okay, good. So I intentionally didn't give Rodrigo any guidance to see what he was going to do here. This is different because we have the 3x out here, right? So Rodrigo is saying, hey, look, we have to deal with that. That's still part of our answer. So Rodrigo said, let's put the 3x like this in parentheses, right? And then, or 3x, and then you said put a parentheses. Everyone? Yes? And now do the grouping on the inside part. So Rodrigo, continue. So these have an x in common, right? So you're going to put that x here. And then what, Rodrigo? Another parentheses, okay? And what goes in that parentheses, Rodrigo? Y minus 2. Everyone see that? It's like if you just take this out, right? Take that. We're just doing grouping. It's just we have to keep track of this now. It needs to continue and stay with us the whole time. All right, you want to pass it off or you want to keep going? Keep going? Okay, so what next? Put y minus 2 in parentheses. Notice I've been leaving myself some space here because I want to be able to fill this in with a number. So Rodrigo, what number is going to go here that when you distribute it through, you get back those two? -1 or -1? Do you all agree? Okay. Now there's one more thing, Rodrigo. I think you know what it is that I'm missing. I have to close the parenthesis. Okay, that parenthesis right there closes off this parenthesis. That's it. Okay. Tiani? She's just not here. We're not breaking this. I think she's just not here. Caroline? Yes. Where are you? Okay, there you are. Caroline, you know what to do now?
Bring the 3x down.
Okay, going to bring this 3x down.
And then parentheses.
Mm-hmm.
Put the y minus 2.
Good.
In different set of parentheses, put the x minus 1.
Perfect. Yep. Okay, so all she did is brought this down and then realized that this we're going to do rewriting it the way we did before, right? We're going to do what they have in common, write it down, and then what's in front of each one, write it down, but we have the 3x in front. So now we have factored it completely. Good? All right. So you think you could handle one of those? Okay, so what I'm thinking, let's see, time. I don't know about time. Let's move on. I was thinking about giving you all a like an in-class group quiz over this, like for the last 20 minutes, and maybe I could crank out the last test and be able to give you your test back, but I don't know if I'm going to have enough time. Okay, now let's move on to 3 terms. And you know what? I think I'll start with the one we started the class with. How about we do that? What if we wanted to factor, you'll have to remind me, this was it, right? Because I had messed up the middle piece, but that was it after I fixed the mistake, right? Now we know what the answer to this is, right? We know because of the way I started class. So the question is, can we get back to that, right? So the first step is GCF. Okay, so you look, do they all have anything in common? No numbers, no letters, so no GCF. So then we count the terms. 1, 2, 3. We have 3 terms. When you have three terms, I told you, you're going to, what? When you have three terms? Okay, it's either going to be the AC method or it's going to be guess and check. Now, I'm not going to do the guess and check, okay? I'm not going to do it only because, like I said earlier, like it takes time to get good at this. And I know some of you in here probably can do guess and check right now and factor this, and if you can, I want you to do it, okay? So right now, if you can just look at that and guess and check and factor, do that on the test, do that for the rest of this class. I'm only showing the AC method for people who are looking at that going, I have no idea what to do with that. Understand? Because I need to give that group of people something, right? Okay, so the way the AC method works is as follows. What you're going to do is you're going to look at your three terms. You're going to identify the coefficients of each of the terms. So the coefficient is the number. There's a 1 here, there's a -2 here, there's a -8 there, right? Okay, so whenever we write quadratics, don't write this down. Whenever we write a general quadratic, we write it like this. We say ax squared plus bx plus c. The a is the number in front of this, and the c is the number in the back. The method that I'm using right now, called the AC method, comes from the idea that the first step for this method is to take that number and multiply it times that one. Okay? So I'm multiplying the a times the c, right? That's what I'm doing, and that's why they call it the AC method. But for us, we don't need that. Just multiply the first number times the second one and write it down. It's -8, right? And there's all sorts of little cute ways you can teach this. I'm just going to do it the way that a lot of us do it here. What we're going to do is we're going to draw a little, like this big X. So I'm putting this here, okay? And then I'm going to put a number right here. And that number is always going to be the B, which is going to be this number. So what is it? -2, right? That goes here. So I have this number on top, -8, and I have this number on the bottom, -2. And what I do now is, well, what you do now is you try and think about two numbers. You have to come up with two numbers right now that will multiply. So I'm going to write this down for the first one. You must find two numbers which will multiply to be -8, but also add to be -2. Right? So if this number would have been -9 and this number would have been 5, you have to come up with two numbers that multiply to be -9 and add up to be 5. Right? So this is always going to be the same. It's just this and this changed from problem to problem. So the way you can do this, well, just think about it, right? See if it's easy or not. Is this easy for you to come up with two numbers that multiply to be this and add up to be this? What numbers are they? 2 and 4. 2 and 4 multiply to be 8, not -8. -2 and +4, but that adds up to be -4 and +2. Okay, so we have to play this game with numbers and try and figure out what's going to work. So if you can just think of it, great. But if you can't just think of it, here's the way that I approach it. I always start with this number up here, and I just start figuring out what multiplies to be -8. So I always start with 1. Would you agree that 1 and -8 multiply to be -8? Right? Okay. But what do those add up to be? Those add to be what? -7, right? 1, and then you're basically taking, and that's not going to work, right? Another way that I could get -8 would be to switch those, -1 and +8. That would give me -8 if I multiplied those, right? But what do those add up to be? 7. That's not going to work. Then I started with 1, right? 1 times -8. The next number I go to is 2. So does 2 multiply? Let's see, 2 and what? 2 and -4, right? That would give you -8. And what do those add up to be? 2 take away 4, that's -2, right? That one works. You follow that? Okay, so once you find the two numbers, you put them here. That just fills out your little chart thing. And it does not matter what order you put them in, okay? Very important. These, if someone else did them the other way around, it's okay. It's okay. All right, so now we move to the next step. What we're going to do now is we're going to take this original thing that had 3 terms in it, right? And we're going to rewrite it. Now, I'm going to write it down. I'm going to pull a stick, and I want somebody to tell me what I did. All right. Macy? Macy. Okay, did you have time to look at it? Okay.
You just separated, well, you factored the negative 2x into the 2x minus 1.
Okay, so you see, Macy noticed that, the x squared didn't change, right? The minus 8 didn't change. The only thing that changed in my next line is that I decided to take this, and instead of writing it as negative 2x, I wrote it as what? Positive 2x minus 4x. Is that still negative 2x? Right? It still is, right? And where did the positive 2 and the negative 4 come from, Macy? It came from these two numbers, right? See how I have positive 2 here? That came from that 2. And this negative 4 came from this negative 4. Now, Macy, why do you think it is that I did that? I mean, like, why would you ever go and make something that's as nice as negative 2x into something more complicated like this? Why would I do that? Now I have 4 terms. See? Do you see I have 4 terms now? And if I have 4 terms, I can do grouping. Okay, so the whole idea behind this AC method is that you start with 3 terms, you play this game to come up with these numbers so that you can get to 4 terms, and then you just apply the grouping. All right? So let's do that next step. Good job, Macy. Devin. We're going to do grouping, right? So when you do grouping, where am I going to draw the slash here? Before the negative 4x, right? So right here. Okay. So Devin, on these first 2, what's a GCF? X. So you pull the x. What would be in this parentheses, Devin? So you pulled an x from here, right? So what's left? You have 2 x's, right? So you pulled just one x here, okay? And then you pulled the x out of this, positive 2, good. Okay? Now, if grouping's going to work, what do you need in this other parenthesis? Same thing here, right? I'll let you finish this, Devin. What do you need to put here so that when you multiply here, you get back this? 4. Close. So if it was positive, it would multiply through and it would still be positive. You need it to be negative, right? So negative here, negative 4x, negative 8. That will work, right? Okay. We're almost there. You may as well finish it off. These two things match, right? So
would it be the x plus 2?
Uh-huh.
The exponent would be x negative 4.
And then the next one would be x minus 4. There it is. So we got it back, didn't we? I started this whole idea today. I put this on the board and I said, hey, can everyone get from here to here? We said yes. And I said, we need to be able to get from here back to here. Right? And to do it, we needed this weird AC method thing along with grouping to do it. Now, if you can do guess and check, like I said, that's the way to go, because you can go from here to here without any steps. Just all happens up here. Okay. Ready for another one? Y'all are so thrilled. I mean, it's just, I can feel the energy. How many of you feel pretty good with guess and check? Like, could have done that problem without, I'm just trying to see where people are. Could have done that problem without doing any of that work. Let me see. Okay, so that's not a huge number of you. It's maybe a third of the class can do guess and check. So that means a lot of you are going to need to be comfortable with this AC method. All right? So let's try another one. Okay, so this problem is dedicated to the guess and checkers in here. The people who raise their hand might struggle with this problem. Maybe not, but my guess is that even if you're good at guess and check, this one might cause a little bit of an issue. But we're going to do AC method, right? Sylvia? Okay. Do you guess and check, or are you going to need the AC? Like in general, do you know guess and check?
I used to.
Okay. Okay, so you've seen it before. Yeah. Okay, so we want even if we're guess and check comfortable, we want to have a fallback, all right? And so the fallback's going to be the AC. So first step, Sylvia? First step? GCF. Do we have a GCF here?
No.
No. Okay, count the terms. 3. So AC or guess and check. All right. So for the AC, what is it we're going to do, Sylvia, to start the AC method out?
Label each one ABC.
We don't need to. You can. That was just, I wanted to show you why we call it AC, because you're going to multiply A times C to start. You can just go ahead and start. And in fact, I like to just put this here and just start this thing out. So what goes in the top part of that thing?
Negative 12.
-12. Okay, so Sylvia's putting -12 here, so she's multiplying 6 times -2, right? Okay, and I'll let you go maybe one more step.
The B positive one.
+1, and that's coming from the number in front of x, all right? Any questions on that? Unless you want to keep going, Sylvia, can you come up with two numbers? Well, you're trying to come up with two numbers that multiply to be what? To be -12, and you're actually trying to figure out two numbers that add up to be 1, right? So that's what Sylvia's doing. She's saying, okay, can I come up with two numbers that multiply to be -12, but add up to be +1? Can you think of those? +4, -3. What do y'all think? Do those multiply to be -12? Yeah. Do they add up to be 1? Yes. So, good. Sylvia's off the hook. Now, again, if you didn't know how to get those two numbers, I would start with 1. I'd do like 1, and let's see, I need to be -12. So 1 and -12, I'd write -1 and +12. I do 2 and -6, I do -2 and +6. I do 3 and -4, I do -3 and +4. So I'm basically looking at all the different ways I can multiply and get -12. Do y'all see that? And then I just start seeing which of these add up to be 1. And this is the only one that works, right? This adds up to be -11, +11, adds up to be -4, +4, adds up to be -1, adds up to be +1. All right? This is tedious, especially if these numbers are really big, but like I said, you got to have a method, right? All right, next in line is Elena. Right, okay. You would think I would have gotten a little more comfortable with that by now. Okay, Elena. What now? This is the critical step now. Don't mess it up. No, I'm kidding.
I'm just taking a guess then. Don't you have to find out how to rank it at 6?
The 6. Okay, so last time, remember, we went from 3 terms to 4 terms at this step, right? So that's the key step. Once you finish this thing out, now what you're going to do is you're going to rewrite this, and it's going to magically go from 3 things to 4 things. All right. So Elena, a way to remember this is that the two ends don't ever change. Okay. So this is just going to be 6x squared, and this -2 is going to be just -2. All right. So don't change these. All you're going to change is the middle one.
Plus 4x minus 3x.
There you go. So plus 4x and minus 3x. I'll even put it in a different color so everyone understands. Plus 4x minus 3x. That's the only thing that's changed, and that's basically replacing that 1x. That 1x is being replaced with 4x minus 3x. And now we group, right? Okay, Elena, I'll let you group. Where do I slash it?
After the 4x, before the negative.
Right there, okay. All right, what's a GCF out of that first one? Be a little careful on that GCF on that first two. 2x, good. So everyone agrees we can pull a 2x? And what's left here?
3x plus 2.
3x plus 2. Everyone good with that? Okay.
We factor out a negative.
You can just factor -1 out. Now, I'm going to write this in parentheses first. Remember, we're trying to make these match, right? So a -1 out in front of this would make that work. Last step, you're there, right? So what goes here?
2x minus 1, or
Two-
parentheses 2x minus 1,
Okay?
times parentheses 3x plus 2.
Okay. There you go. So those people who guess and check, was anyone able to get this without the AC method? You got it? Did it take a little bit of, no? Pretty quick? Okay. So that all depends again on your guess and check background. If you've done enough of it, this just becomes automatic. But you probably spent some time in the past doing that. It's not, again, something that we can just come in here 30, 40 minutes. Everyone's great at guess and check. But we have that method now. Yes? Okay. Let's do this. Let's look at you're going to have to practice, right? I mean, this is the one, well, I would say of all the different sections in terms of homework, this is a very important section. You got to make sure you can do all this factoring, because I will test you on factoring pretty significantly, and the things we do after this are going to depend on factoring. So, you know, it's kind of like, you know, the conversions we did earlier? Like if you never got good at conversions, like you can still get through this class. It's not a big deal. If you can't factor, it's going to be very difficult to finish this class out. So you want to make sure that you understand this section. And practice is what's going to make you good at it. Yeah, let's try. This will be our last one. We'll call it a day, and we'll come back and we'll do the two terms. I'll cut you loose. Well, not that early, but let's do this one. Because I know this is going to come up in the homework, and you're going to be like, what? Okay, so what you should notice here, I'm going to move a little faster through this. All right, GCF? No GCF, right? Okay, count the terms, 1, 2, 3, right? Okay, now this doesn't look exactly like the previous problem in terms of, like, we didn't have these y's here in the previous problem, did we? Okay, so let's see if the AC method will still work. Let's just try it. So I'm going to come over here. What number is going to go here? What number do you think is going to go here? Take that and multiply it times that, right? So what is that? Negative 72. And then what number goes here? The number in front? 1. Okay, so let's see if this is going to work. So now you have to come up with two numbers and multiply to be negative 72, add up to be 1, and you go through all these different possibilities, and eventually you determine it's
Negative 8, positive 9.
-8, +9. Multiplies to be negative 72, adds up to be +1. Okay? So maybe you need to make a list. Get your calculator out. Do something. You've got to generate those numbers. There's no like formula I can give you to generate them. You've got to be able to get them. All right, so now if we follow that same method we've been doing, Elena, remember the ends stay the same, right? That was the whole idea? So the ends, if I leave the ends alone, then I'm going to want to rewrite that middle piece. But Frank, you understand what we're doing here? Okay, that middle piece, Frank, I need to rewrite this. So how am I going to rewrite that here? No parentheses. We're trying to rewrite this 1xy using those two numbers we found. No?
Negative x, or negative 8.
Yeah, -8 negative 8 what though? Negative 8x, xy, see? So we're rewriting the middle term. So it's not just going to be x, it's going to be whatever was here, right? So it's xy, and then, Frank?
And then
Plus 9, xy again. Okay, so do y'all see what we've done there? A little different, right? But same process. And now, Frank, we have 4 terms, right? So 4 terms, we're going to slash, and we're going to go to town here. I'm going to go through this pretty quick. So here I slash. Out of the first 2, I can pull what? What goes into both 12 and 8? 4. So I can pull a 4 out. How about letters? I can pull an X. I'll be left with, nope. I forgot my number. What number's in front there? I need to get 4 to 12, so 3. I need to get x to x squared, right? So x. And then minus what? Minus 2y. So I need to turn 4x into negative 8xy, so I multiply by negative 2y. Now I need that same thing over here. So what number will go out in front of that to make that happen? Plus 3? 3y. Good. And now you're there. So this becomes 3x minus 2y, 4x plus 3y. Does that make sense? If you run into that on the homework, it's the same process. Just be careful that the middle is xy instead. Okay, I said one more, but I lied. This last one, I promise. This last one. Okay, factor this. Okay, so you sit there and you look at it for a little. GCF, there is none. Count the terms, 3 terms. And then you realize, okay, I'm going to go here and make this thing. What number goes on top? 1. What number goes on the bottom? 4. And 2 numbers that multiply to be 1 add up to be 4. Yeah, I mean, what are the numbers that multiply to be 1? Like 1 times 1, right? Or you could have done negative 1 times negative 1, right? Like this multiplies to be 1, that multiplies to be 1. But these don't add up to be 4. And you can sit here and you probably spend the rest of your life looking for them and you're never going to find them. And that's because not every expression factors. Some expressions don't factor. So in this case, if you look at your homework and you look at the answers, they will say here that it is prime. That's what they'll say, it's prime. Which really means not factorable. So not everything factors. That's bad news because. So let's say you're taking a test or a quiz and you set up a problem. You're doing this here and you can't come up with the numbers, like you can't figure them out, and you say prime. You'll still get it wrong. What am I trying to say? Like, let's look at the previous problem. We had this, right? And then I think it was Caroline's. No, it was 72, right? Negative 72 and 1 or something like that. And Caroline said it was negative 8 and 9. So she got the numbers, right? So the numbers do exist for this, right? If you can't come up with them and you put prime, like you're obviously going to get it wrong. Like just because you can't find the numbers doesn't mean that it's prime. It's only prime if the numbers don't exist, which is this case, all right? Okay, that should get you through most of your homework. Try and at least start the beginning of the homework. If you ever get to anything where it has just 2 terms, just skip it for now. Yes?
It's not factor.
Just put prime, yep. Okay, everyone, have a good rest of your week. I'll have those exam grades posted by 2 o'clock today. Again, I apologize. My